So you mentioned that with IoT, we don't know what's going to be built in the future. So how do you build security for something which isn't built yet?
So what we have to do is look at some of the foundational IoT and security technologies that we need to build in there. Fundamentally, because we don't know how these systems are going to work, what we have to do is figure out how to create security in a quanta of computing at the individual node level, at the individual chip level. And then those things will build together. So there are some standard components that we can use. As I said earlier, we can extend the boot process to make sure that we have an authenticated loading and installation and update mechanism, so that only the people who created the first code can sign that code correctly, can encrypt it in such a way that it actually gets on the device. The reality is every device will be breached, will be compromised at some point. What we build, other people can break. But what we need to have is the mechanism to recover and remediate that device to a known good state and then update it to protect it. We have to figure out and have the mentality that we're in an asymmetric war. We have to be right 100% of the time. The attacker only has to be lucky once.
Yeah.
So we have to take the approach that, okay, we're going to do the best job that we can, but we know we're going to have to augment security all the way through. The SBM, Secure Boot Manager, is a really important part of that. The counterpart to that is what's called the root of trust. The root of trust is a component in the chip, or the whole chip if we lock it down tightly, which is immutable and trustworthy. Immutable means that it just can't be changed. The bad guys can't get in there to change it, and therefore when we really reset the device, we can be sure that that part is still correct, functionally correct. We need to be able to put in identities into that root of trust as well. So these really kind of need to move from serial numbers and human identifiable capabilities to true public key infrastructure, or PKI identities. So in this case, these are private keys, which may be 64-bit or 256-bit long. And we maintain the private side inside the root of trust, and we expose the public side into our system. By doing that, we can sign things in such a way that, okay, you've got the key, you can sign a message with it, and I can read it because it's been signed correctly. Okay. These security technologies, PKI and others, have been well tested in traditional InfoSec, information security, but never really brought en masse into the IoT. And this is part of what we're doing with Secure Thingz and with our products such as Embedded Trust and C-Trust. But doing that in such a way that every developer can develop with these tools. Security shouldn't be an a la carte. Security at this level should be a tick box. Yeah. Would you like to protect your intellectual property? Well, that should be a fairly simple yes. Yeah. Would you like to protect your manufacturing to stop cloning and counterfeiting and overproduction? That should be a fairly easy yes. Would you like to have a proper identity which you can act on? Would you like to have an update mechanism which is scalable from the chip up? These, you may want to go in and you may want to tailor with them. That's fine. But fundamentally, everybody would say yes to those questions, and therefore there's a lot of work that we can do to get that framework correct, and then people step on from that. And so, as I say, we want to make this really easy for people. They can just take the tools, they can tick a box to say protect my intellectual property, and it's automatically versioned and encrypted and signed, and therefore nobody can see what's inside that intellectual property, nobody can look at the code base. And it can be sent across the world to the production line, it can be put on the programming machine, it can connect to the chip, and only when it touches the chip does the code check its signature and decode, decrypt into the device and program the device. So we also bring about a huge scalability in manufacturing, where perhaps less trustworthy environments can now be made trustworthy. And therefore we can bring down the cost of manufacturing at scale.